So the question is saying that there are two undirected trees, right? And having n and m nodes labeled from 0 to n minus 1 and 0 to m minus 1 respectively. And you are given 2D integer arrays, as we have given, as 1 and as 2 of length n minus 1, m minus 1, right? Where as content connects two nodes respectively, okay? And then it is saying u is the target node to the node v, and if the node like u is the target node of v if the number of nodes, or you can number of edges on the path from u to v is even, right? So there is a node u and it target to node v, but between that path there is an even number of nodes, right? Note that the node is always target to itself, right? And so we can say return the number of n integers, that is answer, where answer at I is the maximum possible number of result nodes that target to node I of the first tree, if you had the connect to the one of the node from the first to the another tree, right? Like previously we have done, right? Only the change is there, the nodes are even, right? Remember, everything is same, the question is same that we have done study, only changes the node path, number of edges on the path from u to v is even. Okay, so let's continue. We have given in this problem statement, right? So this is the example that we have given in the problem statement, right? And but if you have gone through the statement, right, and till now what you have observed, just think that we have given two trees, right? We have given two trees. Let's suppose these are the edges we have given from the tree 1 and these are the edges from tree 2, right? So two things we have given, edges 1 and edges 2, means we can build the tree. So if you will build the tree, you can see, like if I will build the tree, you remember that study, right? I have used the same tree I have used, right? That is why I'm using again the same tree, so you will understand clearly. Okay, so we have given two trees. Let's suppose if edges we have given, we can build the tree. That is the very simple step you can do, right? So we have given two trees, tree 1, tree 2, right? And tree 1 having n nodes. How many nodes are there? N nodes. And tree 2 is having m nodes, right? Same thing, right? We have given yesterday and today, okay? But how we have built these trees? We have built through the given, what we have given, edges we have given, and that is the simple step you can do, right? Means we have given two trees, tree 1 and tree 2, tree 1 and tree 2. How many nodes? With n nodes in the tree 1, m nodes in the tree 2, right? And we can connect any node from tree 1, 0, 1, 2, 3, 4, any node of the tree 1 from tree 2 with any one edge. We can take any edge, means from any node like 0, 1, 2, 3, 4 from the tree, we can connect any node from tree 1 to any node from tree 2, right? We can connect with one edge, okay? We can take one edge from here to here and we can connect, right, with one edge only. Okay, think what I'm trying to say. Means we can connect any node from tree 1 to any node from the tree 2 with one edge. Let's suppose 0, 0, 1, 0, 2, 0, 3, 0, 4, 0. Let's suppose 0 is a you can say here as a root node. So root node can connect to all of these nodes anywhere. Just think, right? But further understand here the given problem and why the output is coming like this. So for a node u, we say another v is a target. So if this is a node u, this will be node v, right? Means for node u, any of this node that is called u, we can say that another node v, any of these node is a target if the number of edges on the path from u to v is even. Let's suppose from 0 to this 0, or 0 to 1, or 0 to 2, or 0 to 3, or 1 to 0, 2 to 0, like that we have many paths will be there, right? But the path should contains number of edges should be in the path should be even, right? And so it includes the node itself. How? Means 0 itself have a one path, right? And so we can say that. Similarly, we can say for this node that we are connecting the tree to. Means any node from U to V, if we will connect, right, means target we will connect. So the number of edges on the path from U to V is even, right? And also in the statement was saying that, note that the node is always a target to itself, and so it includes the node itself, right? Means number of edges that we are saying, right? The edges on the path should be even, that also, and also including that. Coming back to the example, so what is our job here, right? Our job is to for each node in I, let's take any of these nodes for I in the tree 1, we have to connect it to any node on the tree 2, and we have to maximize how many nodes becomes its target in the tree. If we take from here, we can take how many nodes become its target, right? And we have to do this independently for each I, means each node in of the tree 1, and then we will return here. So if you observe, there is 5 nodes. N is the number of nodes in the example 1 is 5, and so we have to return for each node, we have to return what? Maximum number of nodes that can become in the target, this one. And so total answer is 5. Means let's suppose if I'll talk about the 0, how many you can say number of edges from the path will become, right? Means how many you can say nodes become its target in the node, this one, right? So those output should be here for each nodes. Each nodes is called I hope you understand, guys, right? So what we have done, we have built this tree 1 from the edges 1, and this we have tree 2 we have built from the edges 2, right? So this is the first thing you have to do that. So this is tree 1, right? And if we talk about this 0, right, this 0 through 4, right? Now in the tree 2 we have from 0 to 5, 6, right? Means this is root node and these are leaves node. This is root node and these are leaf nodes, right? You can say, means that smallest leaf node, right? So both trees are valid, guys. I'm trying to say, means both trees are valid. But what does it mean for a node to be a target? Means from 0 to, if we'll go any of this node in the tree 2, right? What is the meaning that node will be a target, right? This is just a mean that it's a very simple meaning that you can reach it with an even number of edges. Simply means all the node can be a target. Simple thing that the node will be a target only if we can reach from this node to here with an even number of nodes, right? Even number of edges, sorry. Okay, and then that thing we have to do. Here is a very tricky thing that we have to understand, is we will use a code parity, right? There is a word we'll use idea, we can say this is an idea, code idea, you can say. We will use a parity. Why will we use? We'll use for if this is even or this is odd. Okay, means It's a very easy trick or idea, you can say. So in a tree, nodes are at even depths from 0, sorry, from 0 to, or if there is more, right? Let's suppose for this one 0, we'll not talk about 1, we'll talk about 2, and if there is after this there is one more, we can 4 and so on. So for even the nodes will become at what, or rather than this, we can say 0, 2, 4 and so on, right? We can say that. Similarly, for odd, we can say that, you understand, right? This 0, 2 and 4 means I'm saying the nodes at even depth from root is 0, right? Root is 0, and these are the at different depth, 0, 1, 2, 3, after this it will become 4, like that, right? So the nodes at an even depth for this, for this, right, for 4, let's suppose 4 and 7 are at even one, this is at even one, right? Means 0, 2 and 4, these are at even, right? So we can say nodes at even depth, right, are in one group. So we can say even group or group 1, we can say. You decide, you can say group 1 or group 2, we can say group 1 also, okay? Then in odd depth, nodes at odd depth will be at 1, depth 1, 3 and 5. Understand, right? Very easy, right? Means these we will use the parity. Either you will go with even parity or odd parity. So there can be two group. So we can say, similarly we can say the even, there will be two groups. There will group 1 for even, right, and we'll take group 2 for odd. We can take that, right? So all the nodes that is at even depth will be in the group 1, and there will be an odd nodes that will be on group 2. We can say that, right? So this way we can use parity in our code, right, to understand the even levels and odd levels, or you can say it even level or odd levels. Yeah, right, we can say. So these are the levels that we will use to understand, right? Just move it. Okay, and so these are the two groups are there. Okay, guys, these are the two groups we'll talk about, right? What does it mean that we have even levels 0 to 4 and odd levels 1 to 3, means group 1, group 2. So every node in the same parity group, right? We can say parity group, parity, or we have already written here, right? So every node in the same parity group is at an even distance from each other, right? Means if there is element, if there is an element in group, right, or there is more nodes in the group 1, let's suppose, right? So every node in the same group, let's have parity group, let's suppose for even, right, is at even distance from each other. Either it is in the even group 1 or group 2, right? So every node in the same parity group, right, what we can say, that they are at even distance from each other. If you talk about this 0, what is the distance between them? So we can say 4 minus 0 is 2. So 2 is also an even distance, right? Similarly, if you talk about from here to 4, it is come like that. Or you can use also odd one. Let's suppose someone is at 3 level, we'll do minus. What we will get? 2, right? Similarly, for even one, let's suppose 2 minus 0 is what? Come 2. Means either you doing or even or odd, right? Every node in this same group, parity group is at what? At even distance from each other. Okay, and that is why we can say that this is statement. Okay, I hope you understand, right? Now think that what are the steps we can follow to implement the code, right? As you can see, right, you can see that for I equal to 0, right, for node 1, we have to connect node 0 from the first tree to the node 0 from the second tree, right? Like that, we will go for all the nodes, right? And for all the nodes, you will calculate this one. I will not go through the depth. We have already seen yesterday how we are going to connect, how we are going to find the number of edges, nodes, right? That we have already seen, right? But just think that how we are going to use that. If we'll talk about how we are going to do, it's very easy, guys, right? How we are going to calculate, right? Just think. I'll give you the 2 or 3 examples, you will understand. Okay, so let's come back to the example 1. What I'm saying is, just see this example, right? So in this example, what we have given? 0, 1, 0, 2, 0, 3, 0, 4, right? Means 0, 1, 2, 3, 4, right? You can see 0, 1, 2, 3, 4, right? What are the even nodes? What are the even numbers? What are the even nodes are there, right? 0, even nodes is 0, 3, and 4. How many nodes are there? 3, right? How many nodes are there at 3? In the tree 1, 0, 1, 2, right? Means 0, 3, and 4 nodes are at even nodes. So this is called 3 count, right? In tree 2, 0, this is at even nodes, 4 and 7. How many nodes are there? 3 nodes. So 3 nodes from here and 3 nodes from here. How many is there? 6. Now think about the odds. How many odds are there? 3 and 2. How many? 5, right? Means if I'll start from here, right, from node 0 in tree 1, and if I want to connect it, so it's even. Count is how many there is? 0, 3, 4 is 3, right? So if we take max from tree 2, from 3 there is how many are there? 3 and 5. 3 is even and 5 is odd, right? So if I'll use here, let's suppose, so in the tree 1, let's suppose from 0 nodes, in tree, right? From 0 node in tree 1, right? What we have given? We have given even group. Even group count is what? We'll do count 1. Count 1, we can say group 1, right? Is even. What are how many elements was there? 3, right? We can say 3. Just come here. 0, 1, 2 means 1, 2, and 3. This is 3. So we can say 3 counts is there, right? So if we will take the max from tree 2, max from tree 2, how many elements will come? Right like this. Okay, how many elements will come? So we can take the max. There is 2 group is there, even having 3 and odd having 5. See, 0, 0, 4 and 7 is 3, and for odd 3 and 2, 5. What will come the max? 5. Now what we have to do? We have to do the sum, right? Means answer at 0 will be what? 3 plus 5. How many elements will be there? Total 8. And you can see 8 is coming. I hope you understand, right? Here. Similarly, if you calculate everything similarly for all the elements, right, you will find that this is happening for all, right? So you will find the answer. I'm just finding for only one, index 0. Index 0 is what? The node 0. You can find for all, right? What you need to do this time, this one will go up, means from the parent one, right? Remember study I told you how to do that. If you will not see daily wise, right, code, obviously will not understand. One, sorry, like this, and then we have done one. Remember? Now you have to talk about for this, like that. Okay, so just go through and understand what I'm trying to say. Okay, so this way you can find the answers at this and you have to return it. So let's understand the code now. Two edges we have given, right? Means we have given two undirected trees, one with n nodes and another with m nodes, right? So you find the m and n nodes, right? Because we have given, so each tree is represented using its edges, right? And so we have to we need to calculate n and m, right? Means one with n nodes and another with m nodes. So you can write the first step to get the number of nodes in each tree, right? So we have also saw in the code the statement that a node is a node u in the target from target a node from u, a node is u, you can say a node u is a target, right, to the node v. Means there is node here and node here, right? So this node is called u and this node calls, let's suppose, a v. So from here to here, right, means this become, for this is source, this become target, right? So if the number of edges between here to here, right, number of nodes from here to here, means target to source to target, if the number of edges between them is even, right, and then we can connect, right, one node from the first tree, from the edge 1 to the second tree. And for each node in the first tree, we want to find out the maximum number of nodes that are target to it after such connection is added. And why we need to do that we have seen, right? But we have to reset after each query. You will not think that I have already calculated that, we will not do that. For each query, what is the each query? Means for all the I. For all the I that we will go. Means I is what? The number of nodes in the S1 is called the queries. So or for each queries, we have to reset it. Understood, right? Let's continue it now. But if you thought, like if you're not thinking like, okay, what is the high level strategy, then you will not able to understand it. Just think that what is the high level strategy? High level strategy is a node is a target to another node if the number of edges between them is even. And in a tree, the depth parity, either we are going for the even and odd, right? Even or odd. Depth parity we have to find. Understand? We have to find the depth parity, right? So in a tree, the depth parity, even or odd, of the nodes, we have to determine the number of edges between them. So once you find the number of edges between them, right, you can find the easily the counts, right? And so we need to color each node based on it's even or odd, right? And after coloring the node with the same parity, that's a target to the each other, you can say nodes with the opposite parity, not the target to the each other. And so you can just take the take the max, right? Means you done that coloring is means you have to define this is will go odd in even, right? So if you, let's suppose nodes with the same parity are target to the each other, then opposite parity will not go. Let's suppose 3 and 5 was there, right? So if we choose 5, we will not take 3, right? And so the answer becomes like this, right? So we'll see the same thing we will see here. Okay. So our idea is to, if we connect node I in the tree 1 to the node of the parity in the tree 2, all the nodes in tree 1 with the same parity as I remains target to it. Means from tree 2, only nodes with the same parity as we are connecting, right? We are connected to the target to it. So the maximum number of nodes target to the node I, right? Means number of same parity nodes in the tree 1 as node I plus maximum number of nodes in the same parity in tree 2. That we will do the sum and we will return it, right? Like we have seen. So first of all, we will find in the step 1, we will find the number of edges here, right? Means we want to compute the number of nodes n and m from number of edges. Means edges dot length will do plus 1, since we'll do plus 1, right? Why we are doing plus 1? Just think. So we want to compute the number of nodes n and m, right? That we are doing from the number of edges, right? But the edges we have given what? Edges dot length we have given. Edges will always be n minus 1, m minus 1. If you go through the statement, you will see how many nodes we have given for this n nodes. There is m nodes, right? And if number of nodes we have given for the tree n, then edges will become what? N minus 1. So if we want to calculate the n back, we have to do plus 1. You understand, right? For n nodes, if n nodes in the tree is there, how many edges will be there? N minus 1. So we just need to do plus 1, right? Since n nodes will have n node. Let me write here. Tree with we can say tree with n nodes, right? Tree with n nodes have n minus 1 edges, we can say, right? Similarly we can say for tree with m nodes having m minus 1 edges. Gotcha, right? So we have to do in the first step, right? Now understand about the parity. 0 is for even depth and 1 for the odd depth. Okay, we'll take like this, and so we will make a group 1, group 2, or color 1, color 2. Either you can say group 1 or say color 1. So we need to do colors at I will store the parity 0 or 1 with the odd of node I in the tree 1. If we will take this color at I, there will be color, right? And color at each index, will store the parity. Parity is either will store 0 or 1, right? 0 for even and odd for 1 in the tree 1, right? Of the node I. Color at 2 at I does the same for the tree 1 that we have done for this one, right? Similarly, we will calculate count 1, count 2, right? Means count even and odd depth for the both tree, right? So count 1 and count 2 we will find, right? So there will be a function build count parity and build count parity, right? So if you have these count parities, what we need to do? So for this function that like we have taken color 1, we will calculate a count 1 group, right? So count 1 and count 2, or you can say group 1, group 2, right? So this function, you can say color nodes, will return how many nodes are even or odd in the tree. So we have already made the color, right? So you can easily understand the depth, right? And our function, we will count the group 1. So for the group 1, we have done for color 1 and color count 1, and the count 1 will contains how many colors are there, right? How many, you can say, nodes are even and odd in the each tree, and you can find it. So count 0 will store even count and count 1 will take odd count, because we have already taken to segregate the colors, right? So colors 1 will contain at 0 it will take even, and at 1 the odd count. Understand, right? So it will be easy for segregate the groups. Then we have the answer, right? We will need to define it. So we will do this. Then the last step, for each node in tree 1, we have to calculate the max one. You know how to do that, right? We know the same tree count. We can do what? we just need to find the parity. How will you find the parity? For there will be all the nodes we have given, right? So we'll color at I, will find the parity, either it's odd and even, right? That we will find. So parity count 1 at parity will the same count, and there will be other tree max. You can find from where count 0 and count at 1, or either 1 or 0. You will find it. You will find the best one. Like this was a 3 and this was a 5, right? So which one is come max? 5 will come max, right? And then we'll do the sum, right? And you will return the result, right? Means for each node in tree, that is called I, right? For each node in tree 1 is called I, right? We need to calculate the maximum possible target nodes. Means we need to count how many nodes in tree 1 are of the same parity as I, means count parity at this. Count parity 1 will find, right? And then we will add how many nodes we have in the tree 2, right? The same parity. We can choose a matching parity nodes to connect. How? We'll find the best one. We can find from the best one, and that you will find for the tree 2. So the resulting output will store in the result at I, and that is your answer, right? I hope you understand, guys, right? Still, if you have any doubt, right, please ping me in the comment box. Now think about the helper function. So there is a method that we will call build and count the parity, right? So we will pass the edges and the color. You just build the adjacency list. You have the edges, so your graph is ready, right? Now you find the parity, right? For finding the parity, you have to write another helper function, DFS assign parity, and you will pass all these things, right? And you will get the odd counts like this, n minus even counts, you will get the odd counts, and then you will return the you can say count, even and out counts, right? So you will have the color. So this function will return the color counts, right? As you know that the parity counts, you can say. So there is a DFS method that will run as a DFS, right? So this is a DFS method that will assign the parity and even count nodes in the array, right? So how the DFS will work, right? So this is a DFS, right? We take node, parent, depth, the graph and its color. Okay, means we have to build, first we will build the graph, will perform DFS. So DFS will perform like this, right? So we'll create adjacency list here, right? So we can assign the graph. We have made the assign the graph, and then we can say that the graph is also coming, right? Means node, parent, depth and the graph. So graph is important. So we will create a adjacency list and will represent the tree. Then we will for each undirected edge, right, in the adjacency list will perform and will initialize the graph, right? Then we will initialize what? The count, right? So initialize the count, right? And then we'll pass the values here, right? We'll count, we initialize with this 0, right? So this is 0 node, means tree node. This is your parent, there is no parent is there. Then we have depth is 0. Then we'll pass the color graph and then the color, right? All these things we will pass, and so the DFS will starts, right? So DFS is to count the tree and count the parity. How we are going to find? You will find the even, and even you will find the color color at nodes, right? So it will store the value. Similarly, we'll go for all the neighbors nodes. You will do the same thing, check both are not same, parent and neighbor should not be same, otherwise find the count and return the count, right? Means we want to determine the parity of this node based on the depth from the root, right? And we will color the node and will increment the count, right? And for all that we will go for all its children, we'll visit all the children excluding the parent one, right? We have to exclude the parent to prevent going back, right? So you will not go in infinite loop, okay? And recursively will traverse deeper nodes and you will find the all the, you can say, even count, okay? So if you'll talk about the we can say time complexity and space complexity, right? So we know we have n and m nodes we have, right? We have built the graph, we have colored the graph, right? And we have also looked through the all the nodes, right? So everything we have done through the n and m, right? N and m. So the total complexity will become what? Tc O of m plus n, like this. Okay. So let me know in the comment box what will the space complexity, guys. Thank you for watching this video. Let me know if you have any doubt in this video. And thank you for watching till now, and please subscribe this channel. If you still have any doubt, please ping me in the comment box, right? If you learn anything here in this video, please give thumbs up, right? And don't forget to subscribe for more Leetcode breakouts like this one, and drop your favorite problem in the comment box. So I'll see you in the next one. Thank you for watching this video.